Hello everyone, welcome back to OLMJ. Today I am back with another video where we'll be discussing the maths questions from this year's pre-score paper of Allen. So this paper has really good maths questions and today we'll be discussing the first three questions. So the first question, we have to find a limit x tending to 0, 1 by x raised to the power 4 minus integral from 0 to x square e raised to the power minus u square du whole divided by x raised to the power 6. Okay, first of all, we need to notice that if x is tending to 0, then this term is tending to infinity, right? So there must be a 1 raised to power x4 in this term also, so that it gets cancelled with the plus 1 by x raised to power 4. Only then a limit will exist. If this does not get cancelled, then we cannot obtain the limit, right? Okay, so notice that we don't know the integration of this e raised to power minus x squared dx, right? This is a Gaussian integral which is used in quantum physics and chemistry, and you will learn it in your BTech first year. So right now we don't know the integral of this expression, right? But notice how this is from 0 to x square. So the value of u here is very small, right? Because x is tending to 0. So we are evaluating this integration very close to 0. So we can use the Taylor series since u will be tending to 0, right? Because the limits are from 0 to x square. So u will also be very small in this location. So we can use the Taylor series. So Taylor series for e raised to power minus u square is given as 1 minus u square plus u raised to power 4 by 2 and so on. So we can integrate this. So if we put this term, this expression instead of e raised to power minus u square, then we can integrate it to get x raised to power x square minus x raised to power 6 by 3 plus x raised to power 10 by 10 and so on. So when we put the value of integration here, replace this integration with this thing, then finally we will get that this 1 raised to power x raised to power 1 by x raised to power 4 minus 1 by x raised to power 4 gets cancelled, and there is 1 by 3, and there then will be other terms like this x raised to power 10 by 10 will get divided by x raised to power 6. There will be terms like x raised to power 4 by 10 and so on, and this will be very small since x is tending to 0, so we can neglect these small values, right? So our final answer will be 1 by 3 only. So I have another method for solving the first question. So if you see, if I take the LCM here, it will become x square minus integration from 0 to x square e raised to power minus u square du by x raised to power 6, and this will be a fraction of the form 0 by 0 because x is tending to 0, so x raised to power 6 will also tend to 0, and the numerator will be tending to 0 since the limits are very close to each other, so integration will be also 0 and this is also 0, so the numerator is also 0. So 0 by 0 form can be solved using the L'Hopital rule, and first we need to differentiate the numerator and differentiate the denominator, and then we can join them, right? So for differentiating the numerator, you need to know how to differentiate an integral, and to differentiate the integral we use the fundamental theorem of calculus, which says that if capital Fx is an integral from a to gx, where gx is also a function of x, right? This is not a constant, this is a function of x, and the inside the integration we have small ft dt. So the differentiation of capital Fx would be, if the limit is a function of x, then we put it in the small f, and then we differentiate the limit itself. So this is a function of x, so we put it inside the small f, so f gx multiplied by differentiation of gx. Okay, so the differentiation of this integral would be, since x square is a function of x, so we put it inside it, so e raised to power minus alpha is x square raised to power 2, so it will become e raised to power minus x raised to power 4, right? This will be e raised to power minus x raised to power 4, and then we have to multiply the differentiation of this, which is 2x. Okay, so finally we get the differentiation of ix as this, And then we can differentiate this also. So this will be 2x, this will be 6 multiplied by x raised to power 5, and this is the differentiation of the integral. Now if I divide if I take 2 common and 6 common, so I will be left with 1 by 3 and multiplied by 1 minus e raised to power minus x raised to power 4 divided by x raised to power 4. And if I take x raised to the power 4 as y, then I will get this, right? Because x raised to the power 4 is common here and here. And we know that since the again we are using the Taylor series of e raised to power minus y, which is 1 minus y plus y square by 2. So if I put it here, I will get 1 by 3, 1 minus y plus y square by 2, and so on, divided by y. So 1 and 1 will get cancelled. I will be left with plus y and some very small terms. So 1 by 3 multiplied by y plus some small terms which we can ignore, divide by y. So y and y gets cancelled, so we are left with 1 by 3. So these were the two methods of solving this nice question. Moving on to question number 2. This is also a very nice question. So it says that let fx be, so we have three moduluses, right? First modulus is for this x, and then second modulus is for, so I will write it. First modulus is modulus of x. Second is modulus of x minus 1. Third is modulus of x minus 1 minus 1, right? So we have three layers of moduli, and gx is defined as max of ft, where t is between x and x plus 1, where x is a real number. So we have to find the points of non-differentiability of gx. So first let us focus on defining this fx, right? Fx will be defined differently for different values of x since there is modulus. So minus will get converted into plus and so on. Let us analyze it thoroughly. So let us analyze the first mod. So the first mod is modulus of x, right? So modulus of x will be, it will remain x if x is greater than 0, and it will be minus x if x is less than 0, right? Because if x is less than 0, then it is already minus, so we have to put a minus sign before it to make it positive. Okay, so there are two different cases possible now, right? When x is less than 0 and x is greater than 0. So when x is greater than 0, then we analyze the second mod. So the second mod will become, since modulus of x is x when x is greater than 0, so second modulus will be x minus 1. And if x is less than 0, then we have minus x, so it will be minus x minus 1. Now let us analyze this. So it will be, so when will this be positive? It will be positive when x is greater than 1, right? If x is 2, then 2 minus 1 is 1, which is positive. But if x is between 0 and 1, since x must be greater than 0 for this definition, so if x is between 0 and 1, like 0.5, then it will be minus 0.5, right? 0.5 minus 1 is minus 0.5, so we have to put a minus sign. So it will become x minus 1 if x is greater than 1, and minus x minus 1 if x is between 0 and 1. Similarly, let us analyze this. So this will become, so notice that if x is between minus 1 and 0, then this whole thing would be negative, right? If this is minus 0.5, so minus 0.5 is 0.5 minus 1, so total minus 0.5. So we have to put a minus sign. So it will be x plus 1 if x varies from minus 1 to 0, and minus x minus 1 if x is smaller than minus 1. Because let us take an example where x is less than minus 1, like x is equal to minus 2. So minus of minus 2 is 2, and 2 minus 1 is 1, which is positive. So we can remove the modulus as it is because the inside value is positive when x is less than minus 1. So again we have branching. When x is greater than 1, when x is between 0 and 1, this will be when x is between minus 1 and 0, when x is smaller than minus 1. So we are analyzing the third mod now. So when x is greater than 1, we have x minus 1. So x minus 1 would be x minus 2, right? And this would be minus x. Sorry, this was minus x plus 1. So minus x plus 1 minus 1. So plus 1 and minus 1 gets cancelled. So this is minus x, right? So let us analyze this. This will be positive. The inside thing will be positive when x is greater than 2. So it will be x minus 2 when x is greater than 2 minus x plus 2 when x is less than, x is between 1 and 2. So now let us analyze when x is between 0 and 1, right? So when x is between 0 and 1, so let us assume 0.5. So we have minus 0.5 inside it. So we have to take a minus sign. So we have to take minus x, right? Since x itself is positive and there is a minus sign. So it will be minus of positive, which is minus inside the mod. So we have to take minus outside, right? So it will become plus x for 0 to 1. So these are the final definitions, right? Because this was the final mod. The third third mod is the final mod. Now let us analyze between minus 1 and 0. Between minus 1 and 0, it is x plus 1. So x plus 1 minus 1, because third mod has minus 1. So x plus 1 minus 1 is x only, right? But this x is negative because minus 1 to 0 has only negative values. So we have to take a minus sign outside the mod. So it will be minus x between minus 1 and 0. Now let us analyze this. So it will be minus x minus 1 and this minus 1. So minus x minus 2. So this would be positive if x is less than minus 2, right? So if x is less than minus 2, then it will be positive. So there is no minus sign. And if x is between minus 1 and minus 2, then this will be negative. Assume this x is minus 1.5. So minus of minus 1.5 is plus 1.5. Plus 1.5 minus 2 is minus 0.5. So we have to take a minus sign, right? So minus of minus x minus 2 would be x plus 2. Okay, so our final definition that we have arrived at is that fx is, so for x greater than 2 we have x minus 2. For between 1 and 2 we have minus x plus 2. For 0 to 1 we have x. For minus 1 to 0 we have minus x. For minus 1 to minus 2 we have x plus 2. For less than minus 2 we have minus x minus 2. Okay, so let us now draw the shape of the graph, because if we have to find the number of points of non-differentiability, we can easily see where there are sharp turns in the graph, right? So remember that we have to find the points of non-differentiality for gx, but right now we are drawing the graph for fx. We'll draw the graph of gx after drawing the graph of fx. So for 0 to 1, the fx is x. So on the right side it will be y is equal to x till 1. Then from 1 to 2 it is minus x plus 2. And see that at x is equal to 2 it will become 0. So at x is equal to 2 it will become 0. And after that it has a positive slope. So it will be like this. And on the negative side it will be like this. So on minus 1 x minus x would be plus 1. And on minus 2 this will become 0. And after that it has a negative slope. So it is mirror of the y-axis is acting as a mirror, right? Now let us analyze the gx function. So this was the graph for fx, right? Now gx, how we will draw, let us see. So let me draw fx here also for our reference. So what is gx? Let us start our analysis by analyzing the gx function at x is equal to 0. So gx at x is equal to 0 would be max of ft, where t belongs from 0 to 1, right? So basically g of 0 is the maximum function of maximum value of f from 0 to 1, which is equal to 1, right? So z of 0 will be 1 because this is 1. G of 0 is 1. Now let us see at any point here or here. So plus 1 would be from here to here, right? And for this it will be from here to here. So in this interval the maximum value is 1 only. So till x is equal to 1, the maximum value of f would be 1. So g of x till x of 1, x equal to 1 would be 1. After that it will start decreasing. So let us analyze here. Here it will be from here to here, and this is the maximum point only, right? Till the point where this value becomes equal to this value, right? After that, if we see here, then from here to here this value will be more greater than this value. So we need to find, so the equation of this line was minus x plus 2, and equation of this line was x minus 2. So till the point when x minus 2 minus x plus 2 becomes equal to x plus 1 minus 2, right? Because we are analyzing from x to x plus 1 and x plus 1 will lie on this line. So this means that till x is equal to 3 by 2, this will be the positive line, and after that it will be the positive line. So this will be like till x is equal to 3 by 2, we are getting this line, and after that this line takes over, right? Because if we analyze here, then x plus 1 will be till here, and this is obviously greater than this point. So this line is replacing this line. Now let us analyze on the left hand side of the graph. So on the left hand side of the graph, if we analyze this point, then x will be here and x plus 1 would be somewhere here, and this point is greater than this point. This will happen until we reach equal values on both lines, and after that this point will be greater than the x plus 1 point, because this point will have the x plus 1 point here, which is lesser than this point. So we need to find when will these two be equal. So the graph of this line was minus x and this was x. So minus x is equal to x plus 1, which means that x is equal to minus half. So till minus half, this would have the x plus 1 value here. This would have the x plus 1 value here, right? So this portion will be the maximum value for x0 to x minus half. So this line we have to draw here. And after that, this line becomes the maximum line after minus half. So now let us analyze this line. So if we take a point somewhere here, then plus 1 of this would be somewhere along here. And the maximum value here would be plus 1, right? Because plus 1 is coming between this point and the plus 1 point. So it will be plus 1 till minus 2, because after minus 2, the plus 1 will not lie such that the maximum value is 1. It will lie somewhere here. So till minus 2, maximum value will be 1. After minus 2, let us see. So after minus 2, if the point is somewhere here, then the plus 1 point will be here, which is obviously greater than this point. And this will happen until this point becomes equal to this point. So this will happen when, so this line equation was minus x minus 2. So when minus x minus 2 is equal to, this line's equation was x plus 2. So x plus 1 plus 2, which will give us minus x is equal to x plus 5. So we will get x is equal to minus 5 by 2. So till minus 5 by 2, this line would be dominating. And after minus 5 by 2, this line will dominate. So the graph of gx would be something like this. Okay, so now let us count the points of discontinuity. So 1, 2, 3, 4, 5, 6, 7. So the answer will be 7. This was a bit tough to draw the graph of gx, but if you are clear with what gx is, so you can easily draw it. If you did not understand anything, you can ask in the comment section, or you can rewind and play again. So let us start solving the question 3 now. It is also a very good question. So it is asking us for the value of limit n tending to infinity of log 4 by n square raised to power 1 by n plus log 16 by n square raised to power 1 by n and so on. So the general term would be, so this expression can be written in terms of summation as right, because if we put k is equal to 1, then we will get this term, and if we put k is equal to n, then we will get this term, and if we put k is equal to 2, we will get this, and so on. So this summation is representing this entire expression, and we have to put limit. Now we know that a property of log is, sorry, this was raised to power 1 by n. A property of log is that the expression, so the exponent of this can be brought down here. So this can be written as 1 by n, k is equal to 1 to n ln of 4k square by n square. Now here if you notice, since this is limit n tending to infinity, this thing will tend to 0, and it is multiplied with a series that has infinite terms. So whenever you have this kind of formula, you should always remember that this can be converted into an integral. Let us see how. So if I write this as limit n tending to infinity 1 by n, k is equal to 1 to n ln of 4x square, I have taken x as k by n. Why I have done this, let us see. So you can form infinite rectangles of minimal area using this summation, which is the definition of integration. So at k is equal to 1, this would have turned into 4 by n square. So n is tending to infinity, would have been 0. So this means that x would have been 0. So at x is equal to 0, this log would have given us some value y, and this would have given us 0, right? Which is basically, if we take this as width and take this as height, this ln f4x square as height, then we'll get very small width rectangle with a finite height, because this x square has finite values, because k square by n square would give us finite values. So this would give us infinite number of rectangles with very small area, and this would continue till k is equal to n, where if we put k is equal to n, then n square by n square would be 1. So ln of 4 multiplied by this is tending to 0. So again at the end we will get another rectangle. So this can be thought of as an integral of ln of 4x square dx from 0 to 1, because if we put k is equal to 1, then k square by n square would tend to 0, and if we put k is equal to n, then this will become 1. So this has transformed into this question. This is the question that we need to solve now. So this can be written as ln of 4 plus ln of x square. This is a property of log, that ln ab can be written as ln a plus ln b. And this can be written as ln of 2 raised to power 2 plus this exponent can come down here. So finally, after simplifying, we will get this, and now we need to solve this. So how we will solve this? 2 ln of 2 is a constant, so this will simply get a x multiplied with it, plus, so we need to solve this by using by parts. Now let us see how we will solve this. So if we consider 2 as the first function and ln x as the second function, so we will get 2x ln x minus of 2x by x dx, which will give us 2x ln x minus 2x, and we will combine it with 2 ln 2x. So we will finally get this, and we need to put the limits. So first we put 1, so 2 ln 2 plus this will become 0, and this will become minus 2. Then we need to put 0 here, so this will simply become 0. Now this is a bit difficult to analyze, because this is 0, and at L0 ln x will become minus infinity. So this is 0 into minus infinity form, which is an indeterminate form. So we can transform it into 0 by 0 fraction, and we can apply the L'Hopital rule. So this gives us that this 2x ln x is equal to 0 at x tending to 0. And this will also be 0 because 2x is 0. So we finally get the answer as 2 ln 2 minus 2. This is the final answer. So hope you liked this video. These were the first 3 questions of pre-Allen score of 2025. Let me know if I should continue this series, and let me know if you have any doubts. Don't forget to like and subscribe. Bye.